if he deposits 2,500 every 3 months, starting immediately. Okay, interest is calculated at 12% per annum compounded quarterly. Now, for this question, it's very important for you to also take note of the keywords. So we have got how much there, we have got 5 years, right? It's going to deposit 2,500 every 3 months, starting immediately. Interest is calculated at 12% per annum compounded quarterly. Right now, for this question, the compound period is no longer per month, but it's now every 3 months, which means per quarter. Okay? So, first, we need to calculate what is F. So F is unknown. That's the value that we need to calculate, or that's the constant we need to calculate. Right? Then our N, the number of payments. Now, because Temba is going to start making a payment immediately, it means that T naught is going to be included. So, if we were to draw a timeline, it will look like this. We are going to have T naught there. Now, since it's 5 years and the interest is compounded quarterly, so it means 4 times a year, it will be 5 times 4, which will give you T20. Okay, so that will be T20. Okay, and this is T naught. Right? Since here, instead of making the first payment at T1, the first payment is made there, or the first deposit is done at T0, which means on the day that Tim went to sign all his paperwork, on that very day he deposited a specific amount, which is X. Okay, so our N is going to be equal to 5. In this case, it will be 5 times 4 plus 1, which gives you 21. Okay? Now, you need to be very careful here because this word here, so those two words starting immediately, are very important for you to determine the correct number of payments. Remember, N is the number of payments. Right? Then X is equal to 2,500. Alright? And then our interest is 12% compounded every quarter. So that's 0.12 over 4. So we write our formula F equal to X times 1 plus I raised to the power of n all minus 1 all over I. Okay, then we substitute. So if we substitute there, it will be 2,500 times 1 plus I, which is 0.12 over 4, all raised to the power of 21 minus 1, all over I, which is 0.12 over 4. Right? So, what's the total amount in that savings account? Alright? So I'm sure you can see that this is not very challenging. The most important thing that you need to remember regarding financial maths grade 12, as you shall see later, because there are different types of questions that we are going to talk about, is that you need to understand what the question wants. And you also need to be 100% sure that it's a future value annuity. Okay, I forgot to highlight as well that word, those two words. Those two words, they tell us that it's a future value because money is being invested or money is being saved. Okay, let's move on to the next one. Okay, so this question I took it from the Mind Action series textbook. Okay, the question says 500 Rand is invested each month starting in 1 month's time. Okay, so 500 Rand starting in 1 month's time, which means T0 is not included, into an account paying 16% per annum, compounded monthly. The fund accumulates to 10,000 rand. How many? Okay, how many? Okay, let me use a different color for that. How many payments of 500 rand will be made? Okay, now what does the question want? It wants you to determine N, the number of payments. Okay, so let's highlight that. So we start with F. F is 10,000, and then our N is the one we want to calculate. Then we have X is 500 rand. Our I is 16% per annum, so that's 16% over 12, which is 0.16. Okay, over 12. Okay, then we write our formula F equal to X times 1 plus I raised to the power of N all minus 1 all over I. Okay, then we need to substitute, right? The objective is to calculate this N. Now, before I move on, I just want you to be aware that since the N is an exponent, it means we have to use our knowledge of exponents or logarithms for us to solve it, to solve for that N. Okay? Right. For today, I won't make N the subject. I'll just substitute and simplify. So, if I substitute, that will be 10,000. Okay, that will be 10,000 is equal to 500 times 1 plus 0.16 over 12, all raised to the power of n all minus 1, all over 0.16 over 12. Right, because of the nature of the question, I'm going to calculate some of the stuff in my mind. You can also do your own calculation. Right, we need to calculate that. So I'm going to use my calculator quickly. We can use our knowledge of logarithms. Okay, I'm going to use logarithms. Now, if I use logarithms, there are two ways, okay, of using logarithms. Our base is that. Okay, this is our base. Right? Remember, the base of the exponential is also the base of the logarithm. So I can write this as n is going to be equal to the logarithm to base of 76 over 75 of 19 over 15. Okay? What do you get? Right? If you simplify that, let me bring in my calculator. So that will be shift, okay, where is my logarithm? It's there. So it will be this one here, and then my base is 76, okay, over 75, right, of 19 over 15. And then you get that. So our n is going to be our n. Now this is very important. So we're getting n equal to 17. Okay, our n is equal to 17.85. Okay, I'm going to explain what that fraction means. So it's 17.85. 17.85. Let me use a different calculator. Like this one. So n is going to be 17.85. Okay, so if I were to ask you how many payments, or rather, what is the total number of payments made? Okay, and what does that 0.85 mean? I need an answer for that from someone else. the total number of payments made, okay, is gonna involve 17 payments of full amounts of 500 rand. Okay, there there are gonna be 17 payments, and each payment is gonna be equal to 500 rand. Okay, now the 0.85, it tells us that the last payment, which is the 18th payment, is not going to be equal to 500 rand, but it's going to be a fraction which is 0.85, it's going to be 85% of 500. So in total, 18 payments are made. Out of those 18, 17 are full payments of 500, but the final payment is going to be of about 85% of 500. Okay, so here we need to say, therefore, N is going to be equal to 18 payments. Okay, then that's it. Okay, I just want you to be aware that your knowledge of logarithms is now required under financial maths. That's why we had to do logarithms in term 1. Okay, we use logarithms in financial maths. We also use logarithm in sequences and series.